Okay, 8.5, solving exponential equations. So you will see two types of questions here. One part you will use what you learned in grade 11. So you have an exponential equation. You are going to write both sides with the same base to solve the equation. The second type, you won't be able to do that. So let's say you have this. You cannot write both sides with the same base, and we are going to use logarithm to be able to solve that kind of equation. So that is the lesson part 2. So today we are going to look at part 1, which is kind of review from grade 11. So let's look at the first example. So we have 3 to the power of 5x equals 9 to the power of x minus 1. So you want to write both sides with the same base. So 3 to the power of 5x equals 9 is 3 square. And of course you have power of x minus 1. Okay, so you have a power of a power, you multiply the powers. So expand these, so 2 times x is 2x, 2 times negative 1 is negative 2. Since both sides have the same base, then if they are equal, their exponents must be the same. 5x equals 2x minus 2. So this gives you 3x equals negative 2. X equals negative 2 over 3. Okay, let's look at the next example. So we have 1 over 2 to the power of x plus 4 equals 1 over 16 to the power of 3x. So you can do two things. You can either write both sides with base 1 over 2 or with base 2. If you use 1 over 2, okay, so first you can get rid of that 3x if it is confusing for you. So that gives you 1 over 16 to the power of 3x, because 1 to the power of anything gives you 1. Okay, then now can you see that 1 over 16 is 1 over 2 to the power of 4. So 1 over 2 to the power of x plus 4, and that one is 1 over 2 to the power of 4. And you still have, of course, to the power of 3x. And now this gives you 1 over 2 to the power of 12x. So you have the same base for both sides, then exponents must be the same. X plus 4 equals 12x, and that gives you 4 equals 11x. Therefore x equals 4 over 11. You could also do it this way. So 1 over 2 is 2 to the power of negative 1. So you could say this is 2 to the power of negative 1 to the power of x plus 4. And 1 over 16 is 2 to the power of negative 4. But that should be multiplied by 3x. Okay, therefore you get 2 to the power of negative 12x. And if you solve this, you get negative 1 times x plus 4 equals negative 12x. When you solve, you still get x equals 4 over 11. Both is fine. Let's look at C. We have 9 to the power of 1 minus 2x equals 27 to the power of negative 2x. So 9 and 27 are multiples of 3, so we can write both sides with base 3. So 9 is 3 square, that is raised to the power of 1 minus 2x, and 27 is power of 3 cube, so this is 3 cube. So you have 3 times 2 minus 4, 3 to the power of 2 minus 4x equals 3 to the power of negative 6x. So 2 minus 4x equals negative 6x then. So 2x equals negative 2. We get x equals negative 1. Next one, we see this time 3 different exponents, right? Base 4, 8, 4 and 32. All of them can be written with base 2, right? The 8, 4 and 32 are multiples of 2, therefore they can be written by base 2. So that 8 to the power of x minus 1 is 2 cubed to the power of x minus 1, and 4 to the power of 2x is 2 squared to the power of 2x, and 32 is 2 to the power of 5, so 2 to the power of 5 to the power of 4x. So basically you have 2 to the power of 3x minus 3, so you need to distribute this over 2 to the power of 4x. And let's remember, if you have a division with exponents, if the bases are the same, so if the bases are the same, then you subtract the powers, right? So if we do that, we get 2 to the power of 3x minus 3 minus 4x. And this gives you 2 to the power of minus 3 minus x equals 2 to the power of 20x. So now we can make the powers equal to each other. So we get negative 3 equals 21x. X is negative 3 over 21. Simplify, you get negative 1 over 7. Okay, next example, E. So we see base being square root of 27, and the other base is 3 root 3. So it looks like those are multiples of 3. We can write them with base 3. So square root of 27. 27 is 27 is 3 cubed. Okay. But then you have to take the square root of it. So that gives you 1 over 2 as a rational exponent. So let me take it slowly. First get rid of the radical. So write 27 to the power of 1 over 2. And then it is raised to the power of x plus 5. Okay, let's do that first. And I can move this 3 root 3 to the power of 4x to the numerator by multiplying the exponent by negative 1. So 3 root 3 to the power of negative 4x. Now I'm going to replace 27 with 3 cubed. That gives you 1 over 2, x plus 5 here. And 3 root 3, so 3 is 3 to the power of 1. Root 3 is 3 to the power of 1 over 2. If they are multiplied, you get 3 to the power of 3 over 2. So you add the exponents. So you get 3 to the power of 3 over 2 to the power of negative 4x. finally, so you get 3 to the power of 3 over 2 times x plus 5 here, and the right side, so you need to multiply 3 over 2 times negative 4x. Actually, if you keep it as multiplication, simplifying is gonna be easier, because I also see 3 over 2 here. Okay, you could definitely multiply these two, but now I see 3 over 2 on the left side too. We can easily get rid of it. So let's make the exponents equal to each other now. 3 over 2 times x plus 5 equals 3 over 2 times negative 4x. As you see, there is 3 over 2 on both sides. Then we can divide both sides by 3 over 2, or multiply both sides by 2 over 3 to get rid of it. So that gives us x plus 5 equals negative 4x. So 5x equals negative 5, x equals negative 1. The next one is a little bit different type. This is how you were doing it last year, okay? So you have 5 to the power of x plus 1. So I can write this as 5 to the power of x times 5 to the power of 1. Right? Because when you're multiplying these two, you add the powers, you get x plus 1. Okay, so keep this here as it is. So this means 5 to the power of x times 5. So 5 of those 5 to the power of x. So you have 5 of 5 to the power of x and 1 5 to the power of x. How many in total? Right? You have 5 and you have another one, 6. So you get 6 times 5 to the power of x. It may be harder for some of you to see it, but think it this way. If 5 to the power of x is m, so what do you have here? You have 5m plus m. Well, that is 6m. But that m is 5 to the power of x. One more way of doing it, you may factor out to 5 to the power of x, okay? So from this line, if you factor out 5 to the power of x, from the first term, I get 5. From the second term, I get 1. So this also gives me 6 times 5 to the power of x. So 3 different methods, you can think of. Then of course, to be able to solve this, you need to get rid of that, you need to isolate the exponential piece. So 6 you need to get rid of. Divide both sides by 6, you get 25. 5 to the power of x equals 5 squared, and you get x equals 2. Okay, so the last one is similar. So we're going to write 3 to the power of x plus 3 as 3 to the power of x times 3 to the power of 3. So this 3 cubed is 27. So you get 27 times 3 to the power of x minus 1 times 3 to the power of x. So 27 of 3 to the power of x minus 1 of 3 to the power of x. So you get 26 3 to the power of x. Again, you may take 3 to the power of x is m. So you get 27m minus m, which is 26m. But m is 3 to the power of x. So you get 26 times 3 to the power of x. So divide both sides by 26. You get 3 to the power of x equals 1. 1 can be written as with any base power with power 0, right? I can say 3 to the power of 0 is 1, or 5 to the power of 0 is 1, 10 to the power of 0 is 1. Anything raised to the power of 0 is 1. So if I do that, we get x equals 0 for this.